Hello, everyone. Good morning, good afternoon, and good evening. Dear authors and invited guests, welcome to our technical session 9A. Myself, Shashwat Mani Tripathi, and this session would be moderated by me. On behalf of Global Knowledge Research Foundation and GI Scholastic, it is my great pleasure to welcome you to the 10th International Conference on a Smart Trend in Computing and Communication SMARTCOM 2026, Pune, India. The 10th edition of the conference is being organized in a hybrid mode. The physical event is held in Pune, which is 19 Jan 2026, and the virtual event is being held through the Zoom from 19 to 21st January 2026. I hope you will enjoy the knowledgeable and interactive session through the day. In this session, we have 10 presentations. Each presenter will be given 10 minutes for the presentations and 2 minutes for question and answers. On 9 minutes, I will raise a very gentle reminder. There is another request to all the participants that you all stay connected with us till the closing remark. If you have any query or update, then you can write it to me in a chat box. Just before we start this session, I would like to introduce you all to the chair of this session, Dr. Deepika Saxena. Ma'am is an associate professor at Purnima University, Jaipur, India. With over 15 years of teaching experience, her area of expertise includes cybersecurity, container security, and cloud computing. She is an active member of ACM and IAENG, contributing to teaching, research, and professional activity in her field. Ma'am, would you like to share a quick opening remark with us?
Yes, good morning to all. Thank you for giving this great opportunity, sir. Yes, am I audible?
Yes, ma'am, you are audible.
Today's session is SmartCom 2026, Smart Trends in Computing and Communication.
Yes, ma'am.
I very much interesting on this topic, and I just wait for all these titles of the papers and discuss with the students also. Thank you so much for inviting me this platform. Thank you.
Okay. Now we'd like to start with the papers. Uh, First, we have Chinmay Swami, paper titled A Computer Vision Approach to Pneumonia Prediction Using Deep Learning.
Good morning, sir.
Chinmay, yes.
Sir, shall I start with a presentation, sir?
Huh. Okay, okay.
Okay, sir.
You.
Sir, is my screen visible, sir?
Yes, it is.
Good morning, respected panel members. Today I'm presenting a project titled called A Computer Vision Approach to Pneumonia Prediction Using Deep Learning. Pneumonia is a serious respiratory disease that needs early accurate diagnosis, especially for children and elderly patients. It is time consuming and requires expert radiologists to this project process a CN-based automatic pneumonia detection system. The model is trained on labeled chest X-ray images, uses pre-processing technique, and provides accurate predictions through a Flask-based web application, enabling fast and reliable diagnosis. Pneumonia affects millions of people worldwide, and delayed diagnosis can lead to severe complications. Manual X ray interpretation is subjective and may vary between radiologists. With recent advances in artificial intelligence and deep learning, CNN has shown strong performance in medical image analysis. A project uses CNN to automatically analyze chest x-rays and predict pneumonia through a web-based system, supporting doctors and medical students with quick and unexplainable results. And we have searched so many research papers and we have analyzed. In paper 1, the system focused on domain adaptation but increased complexity and lacked real-time usability. Our system solves this by using a stable annotated dataset and a simpler architecture. From paper 2, we have analyzed there is only a single pre-trained model was used without symptom integration. Our solution combines CNN image output with system-based risk scoring, improving diagnostic accuracy. In paper 3, they used complex architectures with high computational cost, making it unsuitable for low-resource environments. Our system resolves it using uses a lightweight CNN architecture suitable for real-world deployment. In paper 4, they have used high accuracy using heavy models but lacked explainability and user applications. Our system provides confidence scores, visual explanations, and a user-friendly web interface. In research 5, they have focused only on image-based detection, ignored clinical symptoms. Our system integrates symptom-based assessment with image analysis. In paper 6, they relied on EHR data and was limited to post-stroke patients. Our approach uses chest X-ray images, making it suitable for general pneumonia detection. The main research gap identified was in paper 1, there is a drawback like they are focused only on domain adaptation due to limited label data. Our solution was uses a stable annotated data set for training and testing. Maintain simpler architecture for easier implementation. The main problem statement was pneumonia diagnosis mainly depends on manual chest X-ray interpretation, which is slow, subjective, and depends on expert availability. In high patient load and resource limited areas, this leads to delayed or inaccurate diagnosis. Hence, there is a strong need for an automated, fast, and reliable AI-based diagnosis. And our relevance was our system enables early and accurate pneumonia detection. It reduces the workload on radiologists, improves consistency, and supports healthcare in rural and unadvanced areas. It aligns with modern AI-driven digital healthcare solution. The main objective was to automatically detect pneumonia from chest X-ray images to classify pneumonia types such as bacterial, viral, fungal, COVID, etc. To assess severity levels, mild, moderate, and severe, to improve diagnostic accuracy and reduce radiologist workload, to ensure generalized using pre-processing and diverse datasets. Novelty of the system was system provides dual mode pneumonia detection, like image-based detection using CNN, attribute-based prediction using symptoms. This is our proposed work. Chest X-ray images are collected from public datasets like a Kaggle. Images are resized, normalized, and noise is reduced. Data augmentation techniques such as rotation and flipping improve generalization. Pre-processing state like image acquisition, resizing and normalization, noise reduction, data augmentation. This is our workflow. First of all, we upload a chest X-ray, then we enter the symptoms and risk factors, and we'll validate with the user inputs, and we propose the X-ray image. Then we analyze image with the CNN by predicting pneumonia complete confidence score, and we will evaluate symptoms and risk factors. Combine image and symptom analysis, and we display diagnosis, confidence, and explanation. And there will be output like pneumonia is present or not, and severity also will be shown in our project. We use created BGG16 CNN model to extract deep visual features from X-ray images. Global image pooling converts feature maps into a compact feature vector, improving. And the technical feasibility, the project uses proven CNN techniques and publicly available datasets. It can be developed using standard hardware and open source tools. The web-based architecture allows easy deployment and scalability. When it comes to industry impact, our system enables faster diagnosis, reduces dependency on radiologists, and improves patient outcomes. It supports cloud deployment, multiple users, and future extension to other lung diseases. And the market potential was target users include hospitals, diagnostic centers, and teleradiology providers. The system can be offered as a subscription or licensing model and scaled for both small clinics and larger hospitals. This is the front page of front page of our project. In this, we have added AI assistant and we can upload image. After uploading image, the CNN model will check and then will say whether there is a pneumonia or not. If there is no X-ray, we have added a separate page called symptom-based analysis. In this, the user can enter their uh, pa- mm, fever percentage, cough duration, days, chest pain severity. After entering all the details, when we click analyze symptoms, they'll get whether there is a pneumonia or not, and the suggestions like instructions will be given. I conclude our project successfully demonstrates the effectiveness of deep learning for pneumonia detection. By integrating image analysis with symptom assessment and a web based interface, the system provides accurate, fast, and reliable diagnosis support. This work highlights the potential of AI in improving healthcare efficiency and clinical decision making. Here are our some references. Thank you for giving this opportunity and have a nice day today.
Thank you for the presentation. Ma'am, do you have any questions?
Yes. Uh, Aduru, I just see your presentation, and when I check the references, you are not use any latest research paper in this project or in this work. Yes, am I audible?
Yes, ma'am.
Yes, yes. Show me
Ma'am,
your
we,
latest paper, na? Show me your latest research paper. Review reference in your reference. Yes,
ma'am, we have added
2024. Okay,
24, ma'am. Yes, ma'am.
okay, okay, okay. After that, there are no any research in this area.
No, ma'am.
Okay, fine.
When we checked, 2024 is the latest research paper, ma'am.
Okay, okay, no issue. And you are using the secondary data, na, for this analysis work.
Yes, ma'am. Like we
Okay,
have extract X-ray images from Kaggle, ma'am, and have trained those and have used those data in our project, ma'am.
okay, fine.
Okay, ma'am.
Okay, thank you.
Thank you, ma'am.
Thank you.
So next we have Bhavesh Kumar, paper titled Critical Review on Real-Time Progress Monitoring with IoT and BIM Integration in Construction. Bhavesh, are you there? Bhavesh, are you there? Okay. So next we have Chandralekha, paper titled Deformable Graph Convolution Network with Swarm Bipolar Algorithm for Enhanced Dental Caries Detection from Between Radiograph.
Good morning, everyone. Let
Uh,
me share. I hope
you may please start with the presentation.
yeah, I'm sure. Is my screen visible?
Yes, it is.
Good morning, everyone. I am pleased to present our research title that is Deformable Graph Convolutional Network with Swarm Bipolar Algorithm for Enhanced Dental Caries Detection from Biting Radiographs. Our work addresses a critical gap in digital dentistry, leveraging advanced graph based learning and meta heuristic optimization to improve the reliability of early caries diagnosis. Coming to the abstract, to give you a high level overview, dental caries remains a global health challenge affecting nearly 2 billion people. Currently, manual diagnosis is often subjective and prone to error due to a low image contrast and overlapping structures. So, we propose an end to end framework, DEGC and SPA, which integrates noise removal via curvature Kalman filters, invariant feature extraction, and also graph based spatial modeling. So, as we discuss further, this model achieved a remarkable 99.93% accuracy on the Hunt4 dataset. To introduce my problem statement, early indication of proximal and incipient lesions is essential. It is the difference between a simple preventive treatment and an invasive dental procedure. While bite-wing radiographs are the gold standard for visualizing interproximal surfaces, they are difficult to interpret manually. While AI has shown potential, many current models struggle with the irregular shapes of lesions and the spatial clinical relationships between different dental structures. So here you see examples from the Hunt4 Oral Health Study dataset. Notice the green and orange bounding boxes. These represent the complex task of identifying decay in areas where enamel and dentin boundaries can be very faint. These images served as our foundation, providing over 13,000 manually annotated examples to train our algorithm on spatial and structural patterns. Coming to our problem statement, we already have a CNN based model. So why do we need this model? Actually, there are existing systems face three main hurdles. The first one is irregularity. So lesions don't have fixed shapes, which standard CNNs struggle to map. The second issue is inconsistency. Manual interpretation is time consuming and inconsistent. And the third is technical limitations. Many current AI systems suffer from overfitting and poor hyperparameter optimization. Our goal was to create a framework that is invariant to rotation and scaling and optimized for clinical accuracy. Coming to the literature survey, we stood on mostly of the 24 and 25 research papers. Studies by Peresti, Futos, and Amar confirmed that while YOLO and RetinaNet models are effective, their performance is highly dependent on the data quality and they often struggle with generalization. Furthermore, Kusuma and Dini Maharavati recently highlighted how the swarm bipolar algorithm could drastically improve deep learning parameters by balancing exploration and exploitation, a concept we integrated into our final model. Coming to the system architecture, our architecture consists of four distinct stages. The first one is pre-processing. The pre-processing phase includes the Kubacher-Kalman filter for noise suppression. The second stage is the feature extraction. Clifford Fourier Mellin transform ensures the model isn't confused if the radiograph is slightly tilted or scaled. And the third stage is detection. The deformable graph convolutional network models the teeth as nodes in a spatial graph. And the last stage is the optimization. Finally, we use the swarm bipolar algorithm, tuning the network weights for peak performance. Coming to the methodology, the pipeline starts with raw data from Hunt 4 study. By moving from noise reduction to dynamic optimization, we ensure that the final carriers or healthy output is based on refined and clinically relevant data points. To describe the data set, data quality is paramount. We utilize the 13,887 manually annotated bite-wing radiographs from the Hunt 4 study. This data set includes not just images, but also clinical metadata, including demographics and tooth level labels, making it a robust benchmark for AI research. Coming to the pre-processing stage, to explain in detail, we choose the Kubacher-Kalman filter because traditional Gaussian filters often blur the very edges we need to use. CKF removes noise while preserving fine dental structures and enamel dentin boundaries. It effectively handles the nonlinear intensity variations caused by varying bone density or anatomically overlap in radiographs. Coming to the next stage, that is the feature extraction. To ensure the model is rotation invariant, we use the Clifford Fourier Mellin transform. This ensures that whether a radiograph is slightly shifted or scaled, the feature descriptor for a lesion remains consistent. It captures the specific texture and orientation patterns that define early stage decay. And next most crucial step is the detection step. The core of our detection is deformable graph convolutional network. Unlike standard grids, a graph allows us to learn relational dependencies between different parts of the two. So the deformable aspect is key. It allows the sampling grid to stretch and adapt to the irregular, often jagged boundaries of carriage lesion. The final step is the optimization.
You have 1 minute to conclude your presentation.
The optimization uses a swarm bipolar algorithm. There are few more model accuracy and confusion matrix parts which are included to give a more defined set of detection. So to conclude my presentation, the DEGC and SPA framework provides a highly reliable tool for early dental caries detection. By combining advanced pre-processing, invariant features, and optimized graph networks, we achieve state-of-the-art results that can support clinicians in making accurate, objective diagnosis. Ultimately, the technology will help reduce the need for invasive treatments and improve long-term oral health outcomes for patients globally. Thank you for the time. I'm happy to take any questions.
Thank you for the presentation. Ma'am, do you have any questions? Ma'am, do you have any questions?
Hello.
Yes, ma'am.
Yes, sir. Uh, no question, sir. We can proceed.
Okay, ma'am.
Thank
So next we have Sarthak, paper titled Explainable AI Framework for Air Quality Index Prediction. Sarthak, are you there?
Yes, sir. Good morning, sir.
Ah, you may please start with your presentation.
Good morning, respected panel and audience. I am Sarthak Kumar from Manipal University, Jaipur. Today, I will be presenting our work on explainable AI framework for AQI prediction, focusing on both accuracy and transparency using ensemble learning and SHAP. Air quality index prediction is challenging due to non-linear pollutant interactions and spatial temporal variables. Existing deep learning models achieve good accuracy but act as a black boxes, making them unsuitable for public policy decisions. Additionally, most studies are limited to one or two cities and rely on static datasets, lacking real-time IoT integrations. Our model addresses these gaps by combining scalability and real-time sensing and explainability. This slide shows our end-to-end pipelines. We ingest data from two parallel sources, historical CPCB record and real-time IoT sensors. After robust preprocessing and extensive feature engineering, we use a weighted ensemble for gradient boosting models. Finally, we apply shape to each prediction. We use 24,307 historical records from 26 Indian cities spanning from 2015 to 2020. To enable real-time predictions, we design an Arduino-based IoT node transmitting data every 60 seconds via NB-IoT and MQTT protocol, which is power efficient and scalable. Environment data is noisy and incomplete. We use KNN imputation for missing values, IQRZ filtering for outlying removal, and robust scaling for handling skewed pollutant distribution. From six base pollutants, we engineered 99 meaningful features. This includes rolling statistics over 24 hours, 7 days, and 30 days. Pollutants interaction ratios like PM10 and PM2.5. Cyclic temporal encoding and non-linear transformations. This significantly improve the model ability to capture long-time pollution trends. Instead, instead of relying on single models, we use a weighted ensemble of XGBoost, CatBoost, and Light GBM. Hyperparameters were optimized using Optina-based optimizations and GPU acceleration, reducing training time to under 60 seconds, enabling frequent retraining. Our ensemble outperformed individual models across all evaluation matrices. This confirms that combining multiple learners improve both robustness and generalization. Accuracy alone is not enough. Using SHAP, we explain which pollutant influence aqua prediction and by how much. This makes the model suitable for policymakers, environmental agencies, and public health advisors. To conclude, we proposed a scalable, explainable, and real-time AQI prediction framework integrating IoT, ensemble learning, and SHARE. In the futures, we plan to integrate satellite data, expanding to pan-India development, and explore casual explainability. Thank you, and I'll be happy to take any questions.
Thank you for the presentation. Ma'am, do you have any questions? Ma'am, do you have any questions? So we move to the next presentation.
Okay, thank you, sir.
Okay. So next is Jadeja. Paper title Factor Affecting Construction Labor Productivity, a Review.
Am I audible?
Yes, you are audible. You may please start your presentation.
Yes, I'm sharing my screen now. Is my screen visible now?
It is. You may start.
Yes. Good morning, everyone. Today, I will be presenting my review paper named Factors Affecting Construction Labor Productivity. Uh, Introduction. Labor productivity is one of the most critical performance indicators in the construction industry. It alone, the labor cost alone accounts for nearly about 30 to 60% of the total project cost. When productivity is high, the projects are completed on time and within budget. However, low labor productivity leads to delays, cost overruns, financial risk, and other unaccountable uh, problems. Hence, the understanding of key factors which affect the labor productivity is very essential. Research objective. So, the main objective of the research is to identify the most frequently cited critical factor which affect the construction labor productivity. Next, to categorize these factors into four major groups, which are management related factors, labor related factors, some external factors, and other is technology related factors. Next to rank the individual factors and factor categories based on their frequency of occurrence in the literature. The methodology which is used, this follows a systematic literature review approach. Some relevant studies were collected from databases such as Scopus, Web of Science, and Google Scholar using the targeted keywords. Uh, Only peer-reviewed publications which are published between 2020 and 2025 were reviewed. Two-level factor-based description analysis of RII-based studies was performed in which level 1 ranks the individual factors and level 2 result ranks the four categories. Next is the categorization of productivity factors. Uh, First category is management related, which includes supervision, communication, and planning. Next category is labor related factors, which includes labor skills, labor experiences, and the motivation. Next, external factors consist of the weather changes, some design changes, and financial issues which occurs in a construction project. Next is the technology, tools and technologies, which includes BIM, AI, automation adoption, and equipment availability and other equipment related issues. First category is management related factors. These emerge as a management contributor to productivity issues. Now, incompetent supervisors leads to rework and material wastage. Next, effective communication. Effective communication is very crucial for smooth workflow and a proper coordination for the project completion. Next is planning and scheduling. Proper planning and scheduling helps minimizes the problems and conflicts and proposes a smoother workflow. Next is design issues. Now, incomplete or inaccurate designs are a major causes of project delays. Frequent changes or designs can create unavoidable problems, and which also increases the project overall cost and also time. Next is labor related factors. Labor related factors focus on workflow itself. Now, worker skills and experience are the strongest indicators of productivity output. Major role of labor related factors are the worker skills and experiences. Next, motivation, which is influenced by financial incentives and recognition, also plays a major role. Skilled motivated workers Skilled and motivated workers tends to make fewer errors and complete tasks more efficiently. Next category is external related factors. External factors include weather conditions, which can disrupt work schedules and reduce efficiency. Next is frequent design changes. Now, frequent design changes causes confusion, rework, and time loss, which are often plays a major role in uh, many rework and loss of project construction cost and majorly time delays. Financial and payment issues. Financial and payment issues negatively impact worker morale and slows down the overall progress of the construction project. Next is the tools and technology factor. Tools such as BIM and AI has the potential to reduce errors and improve productivity. Next, adoption barriers. Adoption barriers like lack of training and resistance to change still exist. Major in India, many of the major construction projects are small and medium size, uh, which lacks the adoption barriers, which has the adoption barrier of BIM and AI, as adoption of these technologies is very costly. Basic tools. In many projects, even the availability of basic tools and equipments remains a challenge, affecting which majorly affects the productivity at the very ground level. Level one results, which are the top five critical factors. Uh, the top five critical factors were identified in this level one result, which includes worker skills and experience as the most frequently cited factors in the literature. Next is supervision and communication. This follows closely to their direct influence on site performance. Uh, Material availability, which availability of materials, it is majorly caused by factors affect material availability and incomplete or inaccurate design. Also, significantly impact productivity by causing delays and rework. Uh, Next is level two result, which categorizes the which ranks the categories. Now, in this, it is management level two result shows that management related factors dominate, accounting for 55 occurrences total. This is nearly double the contribution of labor related factors. External factors rank third, mainly influenced by weather and material supply. Tools.
You have 1 minute to conclude your presentation.
Okay. Uh, Next is the key findings and discussions. The key findings indicate that the most critical productivity factor are human-centric. Management dominance suggests that productivity problems are fundamentally organizational. Rework and errors are often symptoms of uh, poor planning, supervision, and communication, and technology alone, which cannot improve productivity unless basic management issues and organizational issues are first resolved. Next is limitations and future research. This study is limited by its reliance on frequency-based ranking of top factors. Many reviews suggest region-specific, which may limit the global applicability of the research. Future research should focus more on human barriers and technology adoption challenges. And there is also need for uniform methodologies to evaluate a real-world AI and BIM adoption impacts on productivity. Finally, to conclude, the construction productivity crisis is managerial rather than technical, which is more management related issues and not technical related issues. Technology investment will fail if proper planning and supervision at management level are weak. The industry must prioritize investments in people, leadership, process well before relying on advanced technologies. And thank you for your time and consideration.
Thank you for the presentation. Ma'am, do you have any questions?
No, sir.
Okay, ma'am. So next we have Chinmay Swami. Paper title Future Gazing Harnessing LSTM Networks for Assist Stock Marketing. Chinmay Swami, are you there? Chinmay Swami, are you there? Okay. So next we have Shilpa, paper titled Harnessing Business Analytics to Reduce Food Wastage in Hotel Kitchens.
Hello,
Hello,
Ah,
sir. Good
hello.
morning.
I'm Chinnaswamy. I'm present. Hello.
okay, okay. So you may start, please.
Okay. Actually, sir is not there, so I am one of the second author, Mohammad Tufail Raza. So I am going to present.
Okay.
Okay. So, good morning, respected dignitaries, judges, and fellow participants. I am Mohammad Tufail Raza, and today I will be presenting our research paper that is a future gazing harnessing LSTM networks for astute stock market prediction, which focuses on using the long short-term memory to predict the stock market trends with improved accuracy. By introducing this project, we know that stock market is highly volatile and influenced by the numerous dynamic factors. The traditional statistical models often fail to capture the long-term dependencies in time series data. That's why to address this challenge, our works explored the use of LSTM network, that is a specialized form of recurrent neural networks for intelligent stock market predictions. This stock market prediction can significantly assist the investors in making informed decisions with the exponential growth of financial data. And we are also using the deep learning models to provide an opportunity to extract the meaningful temporal patterns that were previous difficult to analyze. These will provide the visual prediction and accuracy metrics and the short-term forecast also. It also includes the training testing models evaluation, and also it will give the real-time feasibility. Coming to the problem statement, we know that predicting stock prices is challenging as it is due to non-linearity, noise, and sudden market fluctuation. There is also need for the robust and predictive model to assist the investors and an analyst, and also the businesses in decision-making risk management. So existing prediction system either lack accuracy or cannot effectively model long-term historical trends. That's why a robust deep learning based approach is required. The objectives of our work are to analyze the historical stock market data and to build a LSTM based deep learning model for stock market prediction. It uses the time series prediction. According to the time series only, it will predict the upcoming stock market prices. It also improves the prediction accuracy over traditional methods, and also it provide a reliable decision support system for investors. The industry analysis is, we have a different department of industry where we can use this. We can use it in AI in finance, in fintech, in data driven decision, and in also a trend alignment. In finance, we can use is to increase the adoption in algorithmic trading and robust advisors. And in fintech growth, we can give the strong demand for AI powered investment tools. In data driven decisions like predictive analytics for risk management, we can use this, and it also align with the new trends like fits into the fintech 4.0 revolution and AI driven finance. Coming to the market potential and the business model, it has a feasible and scalable model that is also commercialized and can be used by the subscription model. In feasibility, we can deployable as cloud-based analytic tools, and for scalability, we can expand across the sectors and global markets. We can reach out to the different countries and to the different market like BSE or Kolkata stock, so that we can give and expand it across the countries. Also, we can go to the west side also. It will also commercialized by partnershiping with the fintech startups and the trading apps and investors. There is also a business model which is a subscription model we can use, that is based on predictive and analytic service. We can also integrate to the brokerage apps and trading platforms like Upstocks and Growth, so that we can provide it to a business model and pure commercialization model. It will also give a B2B services for the financial institution. The proposed system architecture is to begins with the historical stock data collection, followed by the pre-processing and normalization. The pre-processed data is fed into a LSTM networks, which learns the temporal patterns and predicts the future stock prices. It gives the incorporation of the Yahoo Finance datasets for real-world scenarios, that gives the addition of forecasting and visualization features. The methodology involves are the data acquisition from stock market sources, data cleaning and feature scaling. Sequence generation for LSTM input is the third step. And next is the model training and validation. And last one is prediction and visualization of result. For data set description, we can say that we can take the historical stock prices such as opening price, closing price, high, low, and trading volume from Yahoo Finance. We also divided the data set into training and testing sets to evaluate the model performance. As LSTM network consists of memory cells and three gates, input gate, forget gate, and output gate, these gates allow the model to retain the relevant information over a long period of times. That is, it is used to make it ideal for the stock market prediction. For the correct progress and expected outcomes, we have collected the data from Yahoo Finance. Pre-processes also, data normalization also done, training and testing also done. The prediction we have reduced via RMSE. Now we have also completed this, and the graphical and interactive dashboard we have used in the web-based Streamlight Python app. And this is a scalable framework so that it will be adaptable to a multiple financial instrument. It is also a user-friendly web interface for a real-time access and predictions. And for the results and performance analysis, we can say that the experimental results demonstrate that the LSTM-based model achieves the higher accuracy compared to the traditional prediction techniques. This predicted trends closely follows the actual market movement. And for the proposed advanced approach, we can give the ability to capture the long-term dependencies, higher prediction accuracy, and reduce the manual analysis. We have also faced some of the challenges like including the handling of noisy data, model tuning, and high computational requirement. It has only some limitation, like model depends on the historical data and cannot fully predict the sudden market crashes. But for future scope and enhancement, we can include the integrated real-time data by incorporating the sentimental analysis news from the social media also, and to deploy in the model as a web-based application. So we can conclude it to that our study also demonstrates that LSTM networks are a powerful tool for astute stock market prediction that offer the improved accuracy and reliable trend forecasting. And so thank you for your time and attention. I would be happy to answer any questions.
Thank you for the presentation. Ma'am, do you have any questions? Ma'am, do you have any questions?
Yes, sir.
हाँ ma'am.
Uh, here is a technical glitch now. That's why
No issue, ma'am. No issue.
you, sir, continue with next person. No?
Okay, ma'am.
Okay, so now can we leave?
No, you have to stay till the closing remark.
Okay,
हाँ.
thank you.
So next we have Bhavesh Kumar. Paper titled Critical Review on Real Time Progress Monitoring with IoT and BIM Integration in Construction.
May I audible, sir?
Yes, you are audible. You may please start with your presentation.
Uh, Sir, my screen is shown.
Yes.
Uh, Good morning, respected sir and all panel members. I am Bhavesh Kumar Labana, and today I will presenting our paper title, Real-Time Progress Monitoring Using IoT in Beam Integration. Prepare for SMARTCOM 2026. Uh, My first introduction construction project today involve multiple stakeholders, complex workflows, and tight deadline. Traditional progress monitoring relies on manual site visits, reports, and photographs. Such methods are time-consuming, subjective, and often delay. Lack of real-time information leads to poor decision making and project delays. Hence, automated and real-time monitoring systems are essential. Problem statement manual monitoring does not reflect real time site conditions, delay in identifying schedule, splillages, and productivity loss, mismatch between planned schedule and actual excavation, limited transparency for project managers and clients, need for an integrated digital monitoring approach. Real-time progress monitoring, continuous tracking of construction activities as they occur on site, captures actually progress data in real time. Progress monitoring, compress plan progress with actual site excavation, support protective corrective actions, and improve schedule and cost control. IoT in construction monitoring, IoT uses sensors, repeat tags, GPS devices, cameras, and wearables. These devices collect live data directly from construction site, track material movement, equipment uses, and labor activity. Monitor environmental conditions such as temperature and humidity, provides automated and objective progress data. IoT strength enable real-time and continuous data collection, reduces dependency on manual inspection and reporting, improves accuracy and reliability of progress data, enhanced accuracy amongst project stakeholders, supports data-driven project management. IoT limitations, high initial investment cost for hardware and installation, data loss or inaccuracy due to HARS site environments, network connectivity and power supply challenges. Maintenance and calibration of sensors require cybersecurity risks related to connected devices. BIM in progress monitoring. BIM provides a digital representation of physical and functional project elements. 4D BIM links time schedule with 3D models. 5D BIM integrated cost information with progress data helps visualize construction sequence and dependency, supports coordination among stakeholders. BIM instance clear visualization of plan, various actual progress, improves communication among designers, contractors, and clients, enable clash detection and construction simulation, enhance planning accuracy and coordination, facilities informed decision making. BIM limitation require skill professional in BIM expertise, time consuming model development and adapting, high software and training cost. Accuracy depends on quality of input data, limited adoption in small projects. IoT BIM integration concept. IoT devices collected real-time site data. Collected data is transmitted to a central database. Data is mapped to corresponding BIM elements. BIM model updates automatically based on site progress. Provides real-time visualization of construction status. IoT sensors BIM model flow. IoT sensors data collection, wireless network data transmission, cloud platform data processing, BIM model visualization and analysis, managers decision making support. Advantages of integration: real-time comparison between plan and actual process, early detection of delays and deviations, improve schedule and cost control, enhance project transparency and collaboration, supports predictive and protective management. Challenges in integration: in interoperability between IoT platforms and BIM software, lack of standardized data exchange formats, high implementation and integration costs, data security and privacy concern, resistance to technology adoption in industry. Critical review and research keep. Most studies focus on pilot or small scale projects, limited validation on large and complex project, scalability and long-term reliability. Not fully explore return of investment, ROI not clear, established, need for standardized and cost-effective frameworks. Conclusion: IoT beam integration significantly improves progress monitoring, provides accurate real-time and transparent project data, supports better decision making and project control. However, practical challenges still exist. Future research should focus on scalable and secure solution. Thank you, sir.
Thank you for the presentation. Ma'am, do you have any questions?
Yes, sir. Bhavesh, please
Yes,
show
sir.
me your framework now.
Yeah, framework. Ma'am, I am not mentioned from framework in
Okay.
this slide, ma'am.
Okay, fine.
Yes, ma'am.
Okay, sir. Thank you.
Okay, ma'am. So next we have Shilpa, paper titled Harnessing Business Analytics to Reduce Food Wastage in Hotel Kitchens.
Good morning, sir.
Huh.
I'm the co-author. I'm Nidhi. Dr.
Okay.
Shilpa. I'm presenting in her absence.
Okay. You may please start with your presentation.
Sure, sir. Is my screen visible?
Yes, it is.
Uh, my topic is harnessing business analytics to reduce food waste in hotel kitchens. The study focuses on how business analytics can reduce food waste in hotel kitchens by improving demand forecasting, inventory control, and operational efficiency. Uh, this is the framework as the global food waste challenge, in which 1.3 billion tons is wasted annually, and then the overproduction and inaccurate demand forecasting are the causes, and also how business analytics solutions can help in bringing sustainability to hotel kitchens. So the motivation is that the food waste increases costs and harms sustainability. Using data-driven analytics, hotels can minimize waste and cut costs and operate kitchens responsibly. Uh, the summary of literature says that the lean practices and technological tools reduce waste, but integrated business analytic based tools approaches are like very limitedly applied in real time. The research gap is that the lack of integrated approaches which are combined with both business analytics and process optimization, and also limited predictive forecasting in hotel kitchens, also insufficient long-term evidence, and minimum focus on ROI and sustainability impact. The research questions are what causes food waste, and then how predictive analytics can forecasting demand be implied, and what are the waste patterns, and how real-time business analytics can improve inventory control. This is the conceptual framework. So the problem statement is that how hotel kitchens suffer from food waste due to overproduction, poor forecasting, and inefficient inventory management, and also business analytic adoption is limited in hospitality sector. The main aim is how business analytics can be used to identify, monitor, and reduce food waste in hotel kitchens. These are the objectives, which are to study and identify the key operational factors contributing to food waste in hotel kitchens, and then to forecast food demand using the historical data to reduce overproduction and minimize waste, to optimize inventory levels through predictive models ensuring efficient use of perishable stock, to identify and analyze patterns in food waste using data analytics for targeted waste reduction strategies. The contributions of the study are it identifies key operational causes of food waste in hotel kitchens, applies demand forecasting using historical data to reduce overproduction, optimizes perishable inventory levels through predictive data analytics, also reveals food waste patterns for targeted waste reduction strategies, supports sustainable and cost efficient hotel operations using analytics. These are the methods and methodologies that I've used in this paper, which are to survey data and operational data from 5 mid to large hotels in Bangalore, which are analyzed using statistical methods and machine learning models. This is the research design, which are point of scale records, inventory logs, food waste logs, staff survey for over 6 months. This is the first objective, which is to study and identify the key operational factors contributing to food waste in hotel kitchens. The key findings are that the overproduction is the largest contributor, which is of 45%, and lack of demand forecasting correlates with higher waste. The objective two is to forecast food demand using historical data to reduce overproduction and minimize waste. The key findings is using random forest, food waste was predicted with high accuracy, that is R square approximately equal to 0.82, which is better forecasting can reduce up to 10 to 15% of overproduction. The objective three is to optimize inventory levels through predictive models, ensuring efficient use of perishable stock. The key findings are that the predictive inventory optimization aligns purchases with actual usage, reducing excess stock spoilage while improving cost efficiency. Objective four is to identify and analyze patterns in food waste using data analytics for targeted waste reduction strategies. This is done using waste pattern clustering. The key findings are that the business analytics reveal that banquets generate twice the food waste of a la carte services. Clustering helps identify high risk food waste days for targeted action. This is the interpretation, which is overproduction is the single largest contributor. Also, predictive clustering can identify high risk waste days. These are the key findings of all the objectives. So to conclude with my presentation, business analytics is an effective tool for reducing food waste, lowering costs, and improving sustainability in hotel kitchens through better forecasting and inventory decisions. The limitations are the study is limited to a small sample and historical data, where the future research should include larger data set, real-time dashboards, and advanced models like LSTM along with staff behavior analysis. So thank you so much for giving us the opportunity to present, to take part in the conference. Thank you so much.
Thank you for the presentation. Ma'am, do you have any questions?
No, sir.
Okay.
Thank you.
So next we have Dhandanu Vaishnavi, paper titled Liveness Detection Using Facial Dynamics and Gaze Response.
Yes, sir. Can I share my screen, sir? Sir, am I audible?
Yes, you are audible. You may please start with your presentation.
Okay, sir. Sir, is the screen visible, sir?
Yes, it is.
Good morning to everyone. My name is Dhandu Vaishnavi. Today I'm here to present my project, Liveness Detection Using Facial Dynamics and Gaze Response. So my project is about liveness detection checks if a person is real or just a photo or video. Here I use three methods. Like here I used the multimodal challenge response engine like eye blink detection, gaze response, and forehead dynamics. Accuracy will depends on lighting variation, data sets condition, and subject movements. Here I enhances the anti-spoofing and boosts facial recognition security. And my project is about the facial recognition is widely used but easily tricked by fake inputs like photos, videos, or masks. This creates a serious security risk in authentication systems. Our project focuses on ensuring only real live faces are accepted. Most current systems use single checks like blinking and use smiling. Hackers can easily bypass this and by using recorded videos or simple tricks. There is a need for a stronger, more dynamic solution. So that purpose, we propose a multimodal approach using three-check eye blinking, gaze tracking, and forehead movement. These randomized methods make it harder to spoof and is implemented as a full web application. The solution is the liveness detection. To solve this, we build the multimodal liveness detection system. Then about existing system. Nowadays, existing systems like use only single trick like blinking or smiling. This can easily spoofed by the attackers. Like single modularity, we call that blink detection. Like user blinks once to prove they are real. This can be faked with a video of a blinking person or otherwise static expressions like smile. User smiles for the camera. A printed photo of a smiling face can fool this. Like and also for head movements, systems ask the user to nod or turn head. A pre-recorded video can easily mimic this. The main problem here is they are predictable. If attackers know the system always asks for a blink or a smile, they can prepare a fake video or photo with that action. So it can this is the main problem in the real world now for security purpose. So I proposed a system. We built a complete end-to-end system to address this weakness. Like uh, it is not just a detection algorithm, but a complete security solution with user login, random checks, and admin monitoring. Here uh, we proposed the system by using three things, which is multimodal challenge, like eye blinks, which is involuntary physical action, and gaze response and forehead movement. This multimodal challenge is shows in a random order to make smoothing almost impossible. Eye blinking detection means the user is asked to blink a set number of times. The system uses the eye aspect ratio AR to confirm real blinking. Then moving to gaze response, random dots appear on the screen. The user must follow them with their eyes. So the media pipe iris tracker measures the eye movement to verify this. Then the forehead movement, the user is asked to raise their eyebrows. The system measures the change in distance between the eyebrow landmarks and a fixed point on the nose. By combining these three, the system forms a strong multi-model defense. When coming to system architecture, this is the workflow for my proposal system. Uh, And our system uses a robust client server model for a real-time proposing. Uh, Here, another weakness is that many existing methods are just basic algorithms without paper system features. They usually do not have user accounts and secure login for individuals, logs or records to track who passed or failed or tried to cheat, admin dashboards to manage users and monitor the system. Because of this, these systems cannot be used safely in real environments like banks, exams, or any other areas. They are detect liveness in one step, but they are not offer complete protection. Here I uses the media pipe to analyze the facial landmarks and runs the liveness detection algorithm, and the result will be stored in the logs. For the process, you can easily go the logs and you can see the result, whether it is pass, fail, or any other thing. Then when coming to implementation, I used the Python Flask and Flask Socket IO for the backend purpose, and for OpenCV and Google MediaPipe for face mesh. I use it, and OpenCV for to detect, I mean, to take the frames of the face when video is captured. Then have used the HTML, CSS, JavaScript for the front end purpose, and SQLite 3 for storing the records and everything. The database keeps details like who attempted, when, and whether they passed or failed. All the records are there in that. Admin analytics, I use pandas and matlogic, and there is no pre-existing public dataset is required. For this, the system algorithms are based on the landmarks, and there is no training classification model is needed here. Conclusion is we successfully designed a liveness detection system that is highly effective against common 2D spoofing attacks. By moving beyond a simple algorithm to a full stack application, we have created a practical and deployable security solution. The advantages for this is more secure than normal face recognition and security, combines multiple features for stronger protection, and it works instantly with a normal thing. And for future scope, you can add this also in my project. Uh, Add 3D vision means here current system is strong against 2D attacks, photos or videos, but 3D mask can still be in a threat. So real human face has natural depth. Masks or screens have a flat or unnatural path. I mean unnatural depth. So you can add the 3D uh, vision. Uh, then train a smarter AI. Use the convolutional neural networks like CNS to detect the subtle spoofing artifacts, detect the screen reflections and detect video replay attacks. So CNN learns differences between real face, photo attacks, video attack. So you can use the technologies like CNN, TensorFlow, or PyTorch deep learning model. We can enhance the system using CNS to automatically learn spoofing pattern and improve accuracy. Hmm. Then scale up means move from small scale deployment to large scale enterprise systems. Currently using SQLite, which is good for prototype small systems, but it is not ideal for large users, high traffic. So you can use that also for future improvements. Replace SQLite with MySQL or cloud databases. You can deploy on cloud. To support enterprise level usage, the system can be scaled using robust databases and cloud deployment. Uh, Thank you, sir. Thank you for giving this wonderful opportunity. Thank you.
Thank you for the presentation. Ma'am, do you have any questions?
No, sir.
Okay.
Okay, sir. Thank you so much, sir.
So next we have Ankita, paper titled Scalable AI System for Early Identification of PCOS and Terminal Cancer Risk in Women. Ankita, are you there? Ankita, are you there? Okay. So next we have Atul, paper titled Sentiment Analysis Driven Forecasting in Cryptocurrency Markets Using Machine Learning Techniques.
Good morning, sir. Wait for 2 minutes. I'm
Okay.
presenting my presentations.
You may please start.
Good morning, all. My name is Atul Thavre, presenting the topic on sentiment analysis driven forecasting in cryptocurrency market using a machine learning techniques. So here is the points, that is the contents of my paper, that is the introduction, background and theoretical principle, literature review, research methodology, uh, then result, data collection tool, conclusion, and references. Here is the introduction is that, so actually these research aim to predict oscillation in cryptocurrency value by sentiment analysis and using machine learning algorithm. So actually this model aim to enhance the construction of the investment policy, establishing a proactive measures for responding some challenges, that is bolstering change in response to market fluctuation in a crypto market. So, so predicting cryptocurrency market is both challenges and opportunity. Unlike a stock market, that is, cryptocurrency have a decentralized beginning, which makes a encrypt market impacted by a social sentiment. Therefore, understanding the online statement to the market is a very important. We should know about the importance of the sentiments and effect of that sentiments on the market. So finding provide evidence on the effectiveness of a forecasting using a machine learning established sentiment model in increasing accuracy. So the ability of the machine learning model to optimize hyperparameters and improve the prediction accuracy is an additional advantage. So, according to the recent study, financial forecasting, sentiment analysis, machine learning can predict the power signal from tweets. So, now we'll study about the background and theoretical principle is there. So, here is some behavior finance and market psychology is there, and there's some limitation of the financial model focuses on the traditional data. Actually, the behavior finance theory and individual is influenced by some emotional and some judgments bias which also manipulate an individual decision making. So actually this work well with information theory and study which demonstrate the power of the group emotion in decision making, show how emotion will impact on decision within a group. So second point is that limitation of the financial model focuses on traditional data. So here, conventional, that is some tools we are using, that is ARIMA and just like a GAR are used lack historical price data as input. So, however, the qualitative factors of a social sentiments and investor emotions are absent at that time. So now EMH, one type of the tool, suggest that market hypothesis exists, hereby market encapsulate all the available information suggest coming from the market. Then now we will now turn to the literature review. First is the in literature review we'll study about the literature we study about the stock market to crypto market, empirical insight and sentiment analysis, machine learning and sentiment analysis. So, train in a market prediction implies that deep learning financial news sentiments social media analytics as a primary traits that we noted. So second point is that empirical insight and sentiment analysis. So actually relationship is more apparent in the crypto world where the price are set to the challenges in the ready threads, some influencer tweets and announcement of a regular changes. Then we'll discuss about the machine learning in a sentiment analysis. Machine learning is a very important technique that influence on the market. So including the LSTM, that is, we will discuss a logistic regression, show how promise in sentiment analysis task will be arises. The development of the machine learning has a revolutionized sentiment analysis that we study in our research. It highlights the effectiveness of a supervised learning technique, such as a support vector machine, etc. Then we will now discuss about the research methodology that we'll discuss in our paper. So this framework, instead of the single system solution, these research employ a multi-stage approach to the study of the role of the sentiment analysis in forecasting a cryptocurrency market. That is to find how this threat impact a digital transaction integrity and the security. In this, that is, we discuss about uh, 2 points. Some points is there, just like a data collection, data pre-processing, feature engineering, sentiment classification model, development, cryptocurrency market forecasting model, measurement, metrics, evolutions, and performance. So now we'll study about the data collection is there. We will collect data from some social media platform. Social media platform just like Twitter, Facebook, Reddit is we are using this type of the social media platform. One sentence will if hire one sentence on the social media that adversely affect or inversely affect on the market. So some news event, some token launches, some influencer promotion is known to influence the sentiment and price movement on fluctuating market. Some financial news article also impact on our market. Our method involves utilizing official API and some web scraping tools configured to collect high value textual data and web pages alongside, that is meta like data like timestamps, that and user ID, retweet and like count also affect. Another thing that is we'll discuss about the historical data. Historical data that we are giving from the previous sources is also affect on that data collection source. Next, we discuss about the data processing. So obtain raw data from a social media and newspaper is also a complex and contains some anomalies will arises. So, so special characters, number, punctuation, market, and emojis are removed from the text if data processing will be happen. Another is a future engineering. So what is mean by future engineering? So using different method of the feature extraction, that is we are using different text can be transferred in the format understandable to machine learning algorithm. So at first the technique term of frequency invest document frequency, that is we calculate the weight of the word in a document compared at the time of the feature engineering. Next is a sentiment classification model development we'll discuss. So after creating a product, the subsequent step is to build a model which classify sentiment. Sentiment may be a positive, sentiment may be a negative, or sentiment may be a neutral. So all these sentiments will affect on our sentiment models. Actually, these sentiments will affect and we develop for some model for this. Next point is that sentiment classification model development. So document that we create for the sentiments, and after creating a product, the subsequent step is to build a model which classify the sentiment as some positive and negative is there. Then
You
crypto
have
market.
1 minute to conclude your presentation.
Okay, sir. Okay. Next is the measurement matrix evolutions is also effect on our market, that is in our sentiments market, in crypto market. This is the diagram that I want to explain. In this diagram, you see that the data collection will be from the different sources, and we pre-processing that data. Then sentiment model we applying for this. Then forecasting model we apply for this. After that, we'll discuss about the next point. Next point is the result is there. So result, we'll discuss about the emotional based sentiment model. What is the effect of this? We'll discuss in this emotional based sentiment model. Then LSTM model, that is long short term memory, long short term memory model, perform well tracking or time based sentiment trend. Then we will discuss about the sentiment integrating forecasting model, that is reduction in prediction mistakes, that is adding a sentiment indicator to the pricing modules and greatly increase the forecasting accuracy in this. Then strong correlation found between the sentiment stores and market moves is there. Next, we discuss about the case study validate the sentiment predictive ability throughout the real event. We will discuss in this. Then we'll discuss about the multitask sentiment and forecasting task transformer model demonstrated the good performance. So its consistent use of the transform model is both sentiment analysis and time forecasting. Input field representation was another discovery there. Then we'll discuss about the multi-sentiment forecasting and transformer model demonstrate the good performance for this. Next, we discuss about the data collection tools. In data collection tools, we for collecting data, we use a sentiment analysis model effectiveness. We discuss in this, in which we'll discuss about the world of the cryptocurrency, where actual conversation and Slack heavily social media posts are quickly affect on the sentiment analysis. This all things are we discuss in this thing. The sentiment market forecasting integrations we discuss in the behavior insight in investigator reaction also affect on the market, in crypto market. Then next point is the impact of the investor analysis is also make some effect on the our crypto market. So in fact, we'll consider about the research from the real life perspective. So you could actually implement a lots of finding in your business regardless of what type of the market player you are. Next, we discuss about the constraint of the new study. New study is also effect on this. So in this new study, just like to begin with the sentiment data, especially that can from the social media quickly become implied. So if you do not remove the board span and anti-disinformation campaign properly, so it will be fake, easily mislead your signal also. Then majority of the models in the study were trained in the English data, so they are not very effective to the local language or in a crypto market where people speak in different languages. Another limitation of the study is that it's mainly concentrated on a major cryptocurrency such as a Bitcoin and Ethernet. So result may not be applicable to the low or high speculated token that have been limited to data coverage. Next point is the future research directions. How we doing in the future? That is the based on this result and weakness of the study, number of the direction of the future research have been possessed. The perhaps the most promising of this is the that is the creation of the real-time sentiment analysis technique that we can revise the prediction upon the arrival of the fresh data. So we multimodal sentiment analysis integrating text-based data along with the graphics we are using in a future. So this is the data collection tool. And now this is the conclusion part. Actually, this paper was aimed at examining of a sentiment analysis and machine learning can be used in the rising of the cryptocurrency market predictions. Through this paper, it has established that sentiment information, especially on a social media site like a Twitter, Reddit, has a large impact on market action and price prediction in the extreme volatile and motive crypto market. Past study will discuss the high valuable, comparatively constant, fail to frequent in identifying the sudden turn generated by the events of the public opinion change or breaking in awareness of the institutional prediction and key factors also affecting. Correlation report and case studies were the main source of the evidence of the fact laid out in the text. The tool introduced of the human side of a trading, which also discussed in our paper, usually ignored in a scientific study, and therefore that is we advocate for a more adaptable and data-driven method of the decision making. So this is conclusion. These are the references I use. Total number there is a total 24 references I will use. So this is all about from my side. Thank you, sir, madam, to giving me
Thank you
such
for
type
the
of opportunity.
presentation.
Thank you.
Ma'am, do you have any questions?
No, sir, it's very long. Okay, thank you.
Okay.
Thank you. Thank you, madam.
So, I sincerely thanks our author for the excellent presentation and contribution in this session and all our participants for being a part of this international conference. I hope this session was informative enough. We, on behalf of our whole team, thank you for the support during the 10th version and all previous 9 versions of the conference. We will be happy to have you in the 11th version in 2027. All the participants would be getting their digital certificate through email within 2 working days. The publication will be live within 7 to 8 months. Kindly cooperate with the team SMARTCOM 2026. I also thanks our session chair, Dr. Deepika Saxena, for chairing this session. A token of appreciation to the chair on behalf of Team SmartCom 2026, a global knowledge research foundation and partners. Thank you for your valuable presence, ma'am. Ma'am, would you like to give a closing remark for us?
Yes, sir. Thank you so much. And when I see these the presentations of all the candidates, and it's a good theme, and the good titles are shared with us. Thank you so much, sir.
Uh, I kindly request all to switch on the camera for a quick snapshot of the virtual conference. Thank you. Have a nice day. Stay safe.
Thank you. Thank you so much.
Thank you, sir.
Thank you.